Alright. Sorry about that, guys. Alright. I don't know what just happened there. Yeah, the whole thing just absolutely crashed. The Streamlabs crashed and my paint crashed. I don't know what happened there. That was really weird. Okay. Anyway, let's try that again. Sorry about that, everybody. That was completely unexpected. Like my whole screen, both my screens went blank, and then I was like, what just happened here? I'm like, okay, sure. The universe doesn't. Is that so? Well, fortunately, the effects of the universe can be counteracted. I'm so sorry, Lysander, I'm so sorry. I was in the middle of just doing the example, and I'm like, what just happened here? I don't understand what just happened here. Okay, let me go back to the main screen here then. Here we go. Go back to the big board. Let's do a subtraction problem. Let's do -3, 5, -7, -2. And we'll subtract that by 4, -5, 6, and -2. Alright, so all we do is the same thing with addition. Just line up the numbers here. So we do -3, -4. So we do 5 minus a -5. Be careful about those sign changes, everybody. -7, -6. And here we get -2 minus a -2. Alright. And so here, what do we get? We get -3 minus 4 is -7. 5 minus -5, that'll become pluses. That'll become a 10. -7 minus 6 is -13. -2 plus 2, what that turns out to be, that'll be 0. Okay. So there we go. The Wi-Fi said no math today. You're right, but the Jess, you're not wrong. The Wi-Fi may have said no math today, but the Wi-Fi last month at the beginning of the semester said there will be exams at the end of the semester that are due. So that is what the Wi-Fi said. I mean, take your pick. I'm just saying. All right. Okay, next. Let's talk about number 5. How do we multiply matrices by a number? So basically, this is basically taking a matrix and just multiplying by a constant k on the outside. So let's do a quick example. Our Lord and Savior, the router, will guide us. That's fair. you go like this, right? You'd be like, oh Nekir-sama, please grant me unto your beautiful bounties of internet content and YouTube videos, especially cat videos, for those are what keep me going every single day. You know, like, yes, exactly. Exactly. And Nekir-sama. Cat videos, there you go. He blessed us with the 5G. This is true. Alright, so let's do this next one here. We're going to do 3 times all of these guys. So essentially, we're just going to do 3 times 2. 3 times -5. 3 times -6. 3 times minus 7. I know this is the most exciting thing that you've ever seen before in your lives. I'm hoping you get the full experience. 6 minus 15 minus 18 and minus 21. Oh boy. There are ways you can combine these together. Of course, you can add, and you can basically add 2 matrices together. You can subtract 2 matrices together. You can combine doing multiplication stuff. I don't know if you guys want to see an example of that or not, but it's really not all that exciting. I'll leave it to you guys. You guys want to see an example of just, I've done adding and subtracting and scalar multiplication, but, you know, if you want to see a combination problem between those 3 concepts, we can do one really fast. It's really not too exciting, but I'll leave it to you guys. Yes? Poll? Yeah, sure. Why not? Alright, let's do a combo example then. Seems like most people are going to want to do the combo example. Alright, let's do it. Alright, it's pretty apparent to me that's going to be the case. Alright, so here's a combo example. Let's say we had 3 times 5 minus 6, 2, and minus 7. Let's say we subtracted that from 4 times. They'll give you They'll give you like 2 matrices, A and B. They'll define it. So they could call this like matrix A. They could call this one matrix B. Whatever. It doesn't matter. Minus 2, minus 8, 1, and 5. Okay, so let's say this is what they had here. And we went ahead and wanted to figure out, okay, well, what's the answer to this particular problem here? Okay. Quick combo example. Okay. So well, we need to, just like regular order of operations, you have to multiply before you add or subtract. So here we do, again, we're going to get 15 here. 15 minus 18, 6, and minus 21. Here we'll do minus, and then we'll multiply the 4 here first. So we get minus 8, minus 32, 4, and 20. And after we do that, we'll go ahead and subtract those from each other here. So we'll do negative 15 minus negative 8, which is positive 23. Negative 18 minus a negative 32, so that's going to be positive 14. 6 minus 4, which is 2. Negative 21 minus 20 is minus 41. And so there you go. Pretty much straight up. That's how you do a combo example, lickety-split. No problem. Very fast. So, all right. Questions about that? All right. That one here, that should be like boom, 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 boom. All right, get that. Get it done, son. All right. Okay. All right, Jess, what do you want me to hydrate with? You want me to hydrate with the Gatorade-ish drink or the water? I'll leave it to you to figure that out. Okay, let's do the next one here. I'm trying to think what I wanted. Ah, there we go. All right. Now comes for the meat and potatoes of section 6.3. Let's talk about the big meat and potatoes of section 6.3, because this is definitely what we need to discuss about. And that is talking about, we talked about addition and subtraction. All right, H2O it is. Thank you. All right. All right, so we're going to be talking about multiplication of a matrix, okay, by another matrix. Now, multiplication with matrices is very different than that of adding and subtracting straight up, okay? Very, very different. We have some rules here that we need to follow in order to see exactly how things will work out. Now, in order for us to actually multiply matrices, we actually need to determine, first and foremost, whether or not we can multiply two matrices together. All right? So I want to take a look here at an example, and then these notes here will start to make a little bit more sense. All right, so we're going to come up with two matrices here, and it'll be my claim that either I can multiply them or I cannot multiply them. So one of those two things will be true here for the problem I'm going to met out. So okay, let me make up two matrices here. So let's say I have 3 minus 7 minus 2 and 1. Let's say I'm going to try and multiply it by minus 2, 5, 1, negative 11. Okay. So here are our two matrices, and we need to determine again whether or not we can actually multiply these two matrices. Now, let's take a good look here and how we can figure that out. Now, what we talked about before is, hey Gemma, hopefully you're doing well. Good afternoon to you. So what we need to determine is, when we talked about setting up matrices, we talked about setting up matrices by talking about rows by columns. That's how we set it up in the calculator there. We entered in, like, we said 3 rows, 4 columns, for example, and then we reduced the matrix down, solve for x, y, z, whatever the case may be. And that's how we found our final answer for that type of matrix. Now, in this case here, we want to do the same things. We want to go and identify the number of rows by the number of columns. Okay, so it always goes rows and then by the number of columns. Okay. Well, I want you to rest up well if you're not feeling too good, Gemma. Okay. Maybe you just need to kind of sit down, just relax today. Put your feet up a little bit. It's fine. Shouldn't be a problem. I know I do every day. Alright, so the first matrix here is going to be a 2-row by 2-column matrix. So that's why I've put here a 2 by 2 matrix. The next matrix here is a 2-row by 3-column matrix. So we have 2 by 3. Okay, so the next matrix here is a 2 by 3 matrix. So we want to check again. We're checking to see if we can even multiply these together. So here's the way it works. To see if we can multiply, if the number of columns from matrix 1, that being this first matrix, equals the number of rows of matrix 2, then you can multiply matrices. Of course, you're more than welcome to stop in anytime, Gemma, and say hello. You know you got me. It's all good. So we have the number of columns here, which is 2, is equal to the number of rows in the second one here. So in this case here, because both of these are equal, that means that we can go ahead and multiply the matrices. Now, there is a second consequence to this as well. Let's talk about that. And that's in regards to the resulting matrix. You can also predict what the shape of the resulting matrix is going to be, because the shape of the resulting matrix, the number of rows and columns of the resulting matrix, will be in the shape of the number of rows of matrix 1 by the number of columns of matrix 2. So if I went ahead and just put a blue box around this, and I put 2 and 3 here, this 2 by 3 matrix, this is the shape of the resulting matrix. Now, we don't know what the numbers are yet, by the way, but we do know that actually we're going to have 2 rows and 3 columns here for the final answer. Okay, that's what we do know. So that's what's very convenient. You do first check out the shapes of each matrix, see how many rows and columns. Again, confirm that you have the number of columns in the first is equal to the number of rows in the second, and then the remaining 2 numbers are the actual shape after multiplying. Okay, now how does it go here in terms of multiplication if we have an example like this? Well, this is where this last guy comes into play. You can always go row by column. Okay, if we're going to do multiplication of matrices, you always go row by column. This is incredibly important here. Okay, row by column. So we're going to go first row, first column. Now, maybe a little tough to see here with the numbers, so space in the way. But here we go. We're going to go row by column. Okay, row by column. So let me show you what's going to happen here, because this part may be a little confusing. Let's take a look. Okay, so we're going to take the first row. I'm going to take the first row, which is 3. I'm going to multiply that by -2. But I'm also going to add first row, first column. So I'm going to multiply each respective number with each other, and I'm going to add those 2 results together, or add those results together here. So I'm going to have 3 times 2 plus -7 times 1. Okay? Again, first row, first column. Next, I'm going to have the first row, second column. First row, second column. So I'm going to have 3 times 3 plus -7 times -7. Again, first row, second column. Now I do first row, third column. So first row, third column. So I have 3 times 5 plus -7 times -10. Is everybody with me here so far? Are there any questions so far? Yeah, well, I have to write it out. You're right, Nicholas. Writing it out if I don't write it out, it will make absolutely no sense. Like, describing in words is very difficult. I'm going to be perfectly honest. Now, you may notice something actually going on here. I'm writing it out. Now, if you take a look at what I've just written out here, okay, we're going to repeat this process here for -2 and 1 here with every column here. Again, second row, first column, second row, second column, second row, third column. But I want you to take a look at how I wrote this out. You can make this process a little bit easier if you start to see a pattern about how I actually wrote out the work. Okay? About how I wrote out the work. Hey, Brian. Which part there, Brian? So again, I did the first, for this one here, I did the first row, first column. That's where I did 3 times -2 plus -7 times 1. So again, that's what I went ahead did here, is that you're multiplying each of the respective spots and adding up the results here together. That's why you have 3 times -2, and you have -7. You add that to -7 times 1. And then you do the same thing. First row, second column, 3 times 3, and you add that to -7 times -7. Now what I want you to look at here, specifically, Brian and everyone else here, is take a look at how I wrote this out. I actually wrote this out intentionally on purpose in a very particular way. You probably can see that I'm putting Your laptop got hacked? Oh no. Well, that's kind of rude. Not you, of course. I want you to take a look at how I wrote this out. Do you notice the numbers I put in parentheses? You guys see the numbers I put in parentheses here? You probably are looking at this and you're like, well, it's kind of weird you would put -2 in parentheses and a 1 and a 3 and a -7 and a 5 and a -10. You probably are looking at that and you're probably saying, well, why did you do that? Why did you put those in parentheses? Well, I do have a specific reason. It's because -2 and 1 came from the column portion of my second part of my second matrix. So what I can do here is, in order to set up what the addition and everything like that for the second row, I'm going to do the second row and then each subsequent columns. I can just bring these numbers down directly. So I can have -2 here, I could have 1 here, I could put 3 here, I could put -7 here, I could put 5 here, I could put -10 here. I could just bring those numbers down because each one of them are part of the column in that second part of the matrix. And now all I have to do is I can just tack on a plus. I'll tack on a plus in between them in just a second. I can put, actually, let's do that now. I can bring down a plus here, that's fine. And all I need to do is the numbers that I'm going to multiply them with, respectively, are going to come from the second row, because this is the second row. All I'm going to do is tack on here the -2 and 1. -2 and 1. -2 and 1. There you go. So if you notice how I actually wrote it out, I did actually do it on purpose because there is a definitive pattern about how you can do those multiplications out if you do it right. I wanted to show that off for you, like, oh, that's a nice little easy way to remember where the numbers go. Okay, well, now you can do it. That isn't so bad, right? Okay, so let's go ahead and see what we get here. We get -6 plus -7. That's -13. 9 plus 49 is 58. We get 15 plus 70, so that's 85. -2 times -2, 4. 4 plus 1 is 5. -2 times 3 is -6. -6 plus -7, -13. We have -2 times 5, which is -10. Minus another 10 is -20. Okay. And that's our final answer for that particular problem. There you go. Yeah, of course. Another example will be incoming. But before we do that here, are there any questions? Anything I'll need to clear up before we move to that next example as requested? And we'll be done. All right. Let's go ahead and do another example, as was asked. I said, okay, fine. Another example, that's what you want, and that's what you'll get. Let's see. All right, so let me do it. All right. Why is it -2 times 1, -1? You mean this? This is 2. Yeah, this is -2 times -2 there, Bernice. I think you accidentally saw that as a 1. Yeah, because this -2 should go with this -2 here. Okay, okay. Oh, okay, okay. Yeah, probably just because I wrote the two really small. So that's on me. That's not your fault. Okay, let's multiply these matrices together. All right. So let's see if we can go ahead and do this here. So can anybody tell me here, what's the shape of this first matrix? What's the shape of this first matrix? What is the shape of this first matrix here? Tell me how many rows and how many columns, ladies and gentlemen. 2 by 3. Sounds good to me. All right. Now, of course, the shape of the second matrix is exactly the same as the first. So, let's answer the question here first. Can we multiply these matrices together? That's the question we're going to ask. Can we multiply these matrices together? And the answer is yes. All right, let's do a poll for this one. Oh. All right, so I see both answers here. Start a poll. And take a short 1-minute poll. Can we multiply these together, yes or no? They have to be the same. What has to be the same, Brian? No channel points for this one. You get a guess. Matrix says A has 2 rows, so matrix B has 3 columns. 3 at the end and 2 at the front. Okay. So 6 people say no, 1 person says yes. All right. Let's take a look back at our rules here. Okay. Let's talk about that first. How can we determine that? The number. Okay, so you kind of got that backwards there, Lysairena. The number of columns from matrix 1 equals the number of rows of matrix 2. Okay, so Brian's correct. 3 at the end and 2 at the front. So another way to remember that. So 3 and 2. We have to determine if these are equal. Now these are certainly not equal to each other. So cannot multiply these two together. So again, cannot multiply. Now don't do it again. All right. I don't know why it does that, but okay. Alright, so again, these are not equal, so unfortunately, I'm not allowed to continue moving forward. Alright, so I want to throw this example in here because I need you to recognize, hey, you need to check first before you do anything else. Alright, because the book and even the homework will like to throw these curveballs, so just need to be aware about that. Now let's do an example where I will assure you you are going to multiply, because I still do need to do an example for that. So let's do that right now. Yep, that's my answer. Can't multiply. Too bad, so sad. Sucks to be us. I don't know. 5 minus 6, 3, 2, minus 10, minus 15. Alright, fine. Whatever. Alright. Give us more of those on the homework. You're like, I just want to hit one radio button, and that's going to be my answer. That makes my life super easy. Okay? I don't have to do jack. Alright? That sounds like easy life, just pushing a button. Right? All you gotta do is push a button. Alright, let's see if we can multiply these together. Now in this case here we have 4 rows and 2 columns. So this is a 4 by 2 matrix. And in this case here we have 2 rows by 3 columns. Alright. That's what we got here. So in this case here, we definitely have these equal to each other. Alright. So this checks out. And our resulting matrix here is going to be a 4 by 3 matrix. Alright. Brian's like, yes! Do it! Alright, so our resulting matrix here, we're going to get a 4 by 3 matrix here once we multiply these together. Let's see what happens when we multiply them together. Alright, I need a lot more space. Alright. Okay, so again, here's the trick behind this. Again, we're going to get a 4 by 3 matrix here. We're going to do the first row, first column. I'm going to have here negative 4. Negative 4 times 5 plus, and then 6 and 2 will go together. Alright. Next, first row, second column. So negative 4 times negative 6 plus 6 times negative 10. And then the first row, third column, negative 4 times 3 plus 6 times negative 15. Okay, so that's the first row here. First row, first column, first row, second column, first row, third column. And now, you can actually, again, you can start filling in the blanks here for the other 3 rows. All you need to do is, again, anything in the parentheses you can just automatically bring down. So, sorry. This 5 would go right underneath that one. That would go 5. 5. Down the 2. Bring down the 2. Down the 2. The nicest part about this is, like I said, this just reduces a lot of the confusion that you may have about where numbers go. If you know it follows a definitive pattern, you can exploit it. An exploitation of these numbers makes our life a lot easier. Okay, again, we can put a plus sign between each of them. All right. All right, there we go. We did the hard part there. Now all we got to do here is just simply put in the rows, okay? So again, the second row is 3 and negative 2. So we do 3 minus 2, 3 minus 2, and 3 and minus 2. Fit that in there. There you go. 0 and minus 2. So 0 minus 2. 0 minus 2. 0 and minus 2. And finally 11 and 7. So 11, 7, 11, 7, and 11 and 7. Alright. Alright, there we go. Got it. Perfect. Perfect, perfect, perfect. Okay. So all we gotta do now is figure out what this is going to equal to, and we're gonna get our final answer. That easy. Okay. Let's figure that out now. So our final answer here, after everything is said and done, I'm gonna go ahead and figure this out here in my head. We got negative 20 plus 12, that's minus 8. Positive 24 minus 60, so that's minus 60, so that's minus 36. Alright, so here we got minus 12 minus 90, so it'll be negative 102. 15 minus 4, 11. Negative 18 plus 20, that's 2. 9 plus 30, 39. 0, we get minus 4. 0 just cancels stuff out. Negative 2, negative 10 is positive 20. Negative 2, negative 15 is 30. And here we get 55 plus 14, so that's 69. Get negative 66 minus 70, that's minus 136. And here we get 33 minus 105. So let's see, what is that here? That's going to be 28 minus 72. All right. And there we go. We got it. Perfect. And so this would be our final answer for that. Easy time, easy life. Any questions about that example? And again, just to showcase one thing off here, you can do this on your calculator. It is entirely possible. Okay, so you can set up these two matrices in your calculator. You can go ahead and multiply those two matrices together, and you will get the same final answer that you have here. So to show this off here, again, we do have the answer here. So we should be able to replicate the answer here. At least let's show off how to do that. Alright. So this is pretty much how we kind of did stuff yesterday with setting up our matrices. We get a second in matrix. I'm going to edit some matrices. Here, again, you do have to identify the shape of your matrix here. So again, we have a 4 by 2 matrix. So again, just enter in the numbers. Okay, so that's the first matrix. You hit second in mode to quit. Second in matrix again. You're going to edit a second matrix. We'll call that matrix B. That's going to be a 2 by 3 matrix according to our problem. Enter in those numbers respectively. This is pretty much a straight up like, hey, just like multiply these together sort of deal. The issue is that in some problems, it just takes longer to do this in the calculator. So, especially when you have bigger matrices. So, and then if I want to multiply these after I entered it in, I hit second in matrix. I go to names. I go to letter A. I hit enter on that. Hit multiply. I hit second in matrix again. Call it matrix B. And then I hit enter. And yeah, does that match what we got? Yeah, good stuff. Alright, that confirms all our answers that we got there. So now you know how to do it that way as well. Alright, easy peasy lemon squeezy. Alright, questions about that? You have to set up both matrices, Brian. So you gotta go through the process that we did here yesterday. You gotta edit the two matrices, put in the numbers, and then you're just gonna straight up just call upon both matrices. When you say names, you go underneath A, whatever your matrix A is, and then you just hit multiply and then second matrix, and you call upon matrix B. Like, there's nothing... That's all you gotta do there, Brian. Like, there's nothing more that you have to do outside of that. It's like multiplying two numbers together, only instead of two numbers, you're just multiplying two matrices, one after the other. That's about it. So, yeah, there's nothing more than that. There's nothing needs to be more than that, in all honesty. So, alright. Now, being on the calculator, we are going to be continuing using this calculator here, but there you go. Alright. Let's go to the... Is this way just as accurate? Of course. But I gotta show you the fundamentals. Brian, if there's one thing you gotta understand, fundamentals are one of the most important things to know. I know sometimes I'll skip certain things. I know sometimes that I will do it the long way. But when I do it the long way, it's just that sometimes I feel like knowing that fundamental is very important. So, to me, if you don't know the fundamentals of something, then understanding where it came from is just not as good. You know, that's why I don't want to rely entirely on the calculator as a crutch. Part of this class is about critical thinking as well. So, even though you're like, well, I can get directly to the final answer really, really fast if I just enter stuff into the calculator. Okay, I get it, alright? I know that, alright? Trust me, it's not like I'm not... Okay, trust me, I'm not dumb and I say, oh, well... Yeah, you just showed us the shortcut way and you did this whole long-winded example to get the same answer. Like, okay. Yeah, I said that's true, but the important part here is the reason why I show you the long-winded way is because you have to understand where it came from. You know, understanding about the fundamentals behind anything about where something came from is fairly important, because if there is a problem, right? If there is a problem, then you can go manually check on your own and you could figure out what that issue is. If you always rely on a machine to tell you what to do, well, then the issue is that you don't really understand the core fundamental problem behind anything. And that's just not math related, that's everything related. You know, so to me, that's the kind of thing that people miss on, is like, people miss about, is like, sometimes you got to go to the old school methods to figure out where the issue is, you know. And you got to look up resources, you got to figure it out, you know, you got to pinpoint the issue. Sometimes you have to critically think, say, hey, this is going on, you know, because you know, things break, things have to be fixed, or, you know, there's always maybe sometimes an issue or some kind of problem that's going to require that kind of thinking. And that, my friend, is the difference between a good worker and a great worker. The difference always comes down to critically thinking and being able to suss out a problem faster than what a machine could tell you in some cases. So sometimes that little bit of extra bit, it can certainly go a long way. So I will say that in relation to that question. And that's not being mad at anyone. That's just like, hey, that's just from my perspective. That's what's been the most helpful thing for me in my life, is like just being able to critically think things through, and, you know, being able to grasp a certain perspective with certain points and everything like that. So then come up with an opinion or a conclusion based on what I see and what I hear and what the devil behind the details is going to be. So all right. All right, any questions? Any questions about that? Hopefully that's not too bad. All right, gotta get next one. Is this? Save it. There we go. All right. All right. So let's take a good look here at the next section here, section 6.4. I wanna, yeah, think, check that. Yeah, okay. So section 6.4 will be the last section of chapter 6. Okay, so just letting you know about this here. I'm not sure how far we'll get through today. I think we'll get through all of it, maybe. Anyway, how do we find the inverse of a matrix? Okay, so we're going to find inverses of a matrix here. Now, I could show you the long method here. The long method would take a while. Again, the reason why I'm not going to showcase the long method is because it uses a similar method in section 6.1 using the Gauss-Jordan elimination method. And we didn't cover that there manually. We did that with the calculator. So again, I went ahead and said, hey, we got to use the calculator to find this inverse. Now, the notation here for inverse is no different. Okay, so if you have A is the matrix, then you have A inverse. That's the matrix inverse. Okay, so the notation here, there's no difference on how we're doing that here in terms of that. Now, let's do an example. And you'll notice that what we just did here on the calculator is not going to be all that crazy. So the way you would manually do it is you put like a little line here. You would have like 1001 and then you'd reverse the sides there. Anyway, I'm not going to do that. I'm just going to go ahead and just do it straight up. So Okay, so I don't know what this inverse is gonna be, but here I can show this off here. So, all right, let's find the inverse of this matrix. We could end up with really ugly numbers, so I'm just gonna kind of run with it. I'll show you one with nice numbers. The first one I'll show you with ugly numbers. So, okay, so the way it works is we need to go ahead and set up our matrix here. We're gonna get second in matrix. We're gonna edit a matrix here. Now in this case here, we have a 3 by 3 matrix. So we'll enter in all the numbers here, specifically. Okay, so we put in all the numbers here into matrix A, and all we have to do is we hit second in mode to quit to the main screen. We want to hit second in matrix again. We want to call upon our matrix A, and all you have to do here, ladies and gentlemen, is hit the x to the -1 key. That's it. So you call upon that matrix you just defined, just hit x to the -1, and then hit enter. Okay, now in this case we end up with pretty ugly numbers, so let's put it as a fraction. Let's see what we get here. Alright, there we go. Slightly a bit better. Yeah, usually you end up with fractions, so just put it in fractional format. -11 halves, 26 over 7, 47 over 14, -11 over 2. Have a great weekend, Blink. Take care of yourself. And to leave early today, but that's okay. He has a good weekend. 24 over 7, 45 over 14. And we have -7 over 2, 15 over 7, 29 over 14. Okay. And this is our inverse of this random matrix I made up. Alright. That's fine. Alright. And that's it. That's all you gotta do. Now, the important part here is that if you multiply these two guys together, let's say this was matrix A and this is matrix B. If you might take a... Whoa, time out. No. Thank you. Alright, so if you take matrix A and multiply it by its inverse, what you'll get is you'll get the identity matrix. The identity matrix, at least in this case, is basically you're putting in ones all down the diagonal. So this is the identity matrix. It'd be like, looks like this in a 3 by 3 case. For 2 by 2 case, it would look like just ones down the diagonal, and then everything else is 0. You get the general gist. So basically that's how it works out. If you take the again, if you go the other direction here, then you also will get the identity matrix. So multiplying these two matrices together will net you the identity matrix, no matter which way you multiply them. In multiplication of matrices, by the way, remember order does matter. Very important to note. Okay, so order matters here. I will showcase a problem here in regards to that in just a second. But honestly speaking, this is all I would like you to do here for inverse of matrices is, again, just straight up set that up on the calculator, hit the fraction key so it puts it in fractional format, and you should be good to go after that. Are there any questions about that? I hope that part there is not too bad. We're going to look at another example here, but you'll see we'll be doing kind of like the last part there. Okay. So the next part I want to talk about here is the multiplicative inverse of a 2x2 matrix. That's number 2. This is just a shortcut method to find in manually the multiplicative inverse of a 2x2 matrix. So I'm just kind of showcasing it off here, be like, oh yeah, here it is. If you want to find it, you can find this via the calculator as well. Really, it's a 2x2 matrix. I mean, just the size is different, but if you want to start off with a 2x2 matrix here, like A, B, C, D, and you want to take the inverse of that, that's what this is equal to. 1 over AD minus BC times this other matrix, times this modified matrix. Okay. Again, I'm not going to make you memorize this whatsoever. You can put that on. So if you were to do a quick example for this, let's put a random 2x2 matrix here. I'll keep it simple. So let's do 1, -2, 3, and -4. Okay, so let's just do a simple one like that. And then let's see what we get here. So you have A, B, C, and D. So A is 1, E is -4. B is minus B, which is -2, minus C, which is 3. Okay. And then we modify this matrix here to reflect D minus B minus C and A. So these two would swap, and then these two guys would change sign, is essentially what the shortcut is. So D here is -4. Minus B is +2. Minus C is -3. And here we got 4, -4, which is oh wait, we swap these, so this should. All right, and then we just put 2 and 2 together by just multiplying here. Again, this is the manual way. Is it that important to me? Not really, but again, just some problems say, hey, why don't you do this? So you know where it came from. So you get -4 plus 6, that's 1/2. Take a half times this. And then just multiply. Get -2, 1, -3/2, and 1/2. And that's it for that. Simple enough. Okay. So let's put it in the calculator. I'll show you that this indeed is the answer. Tricks. I know I'm going through these problems here rather quickly on purpose, so. Okay, and so I have 1, -2, 3, and -4. And then I can go ahead and call upon that matrix here. A, the inverse key, and hit that as a fraction. Math and fractioning. Okay, so you can see that it confirms exactly what the formula had said. All right, nothing too exciting, but there it is. All right, seems fair. All right, questions about that so far? Nope. Okay. So the oh, sorry, Joseph, my fault. Like right here, or do I need to scroll up more, Joseph? Just let me know if I need to scroll up a bit more. So, oh, that's good. Okay. mental calculations there. All right, good. All right, now the last question here for this handout for this section, and is going to be number 3. Number 3 asks, how do we solve a system using the inverse of a matrix? So we've already seen how to solve for systems of equations using elimination. We know how to do that here, but you can also use inverses to actually help you find the solution for, like, say, x, y, and z in a system of equations, and then essentially solve for, just basically get x, y, and z at the end of the day. Now, the way we do that here is we're going to use a quick example to go along with what's written here, is that we can set up the equation using 3 matrices. We have the A matrix, we have the X matrix, which I'll explain in just a second, and the B matrix here. So we have it equal to the B matrix, which is the B matrix here is going to be kind of like the AKA the answer matrix. Okay, so let's take a look at an example here, and let's see how we can work with this. So we'll start off with the system of equations. Okay, so start off with x plus 2y plus 5z and x plus 3y plus 8z equals 3, and then minus x plus y plus 2z plus 3. All right. So let's say that this is what we want to solve for. We want to solve for x, y, and z in this system of equations. Okay, now setting up this matrix here isn't hard to do, but that's not what we're going to do. We're not going to do the same thing that we did here at the beginning of this chapter. Instead of writing an augmented matrix, we're going to break them up into individual pieces. So for example here, we're going to have ax equals b. We're going to rewrite this whole system of equations in terms of matrices. So what I'll have here on the left is I'm going to have all the coefficients here for x, y, and z. So I'm going to have 1, 2, and 5. I'll have 2, 3, and 8. And I'll have minus 1, 1, and 2. This matrix here, and make sure about the signs. Okay, that's correct. This is going to be our matrix A. Okay, this is going to be our matrix A, is just the coefficients of x, y, and z. Next to that will be x. Now this matrix X here is just going to be our XYZ matrix. So the letters that we actually have here. Then we'll have equals. And then our matrix B here in this case is going to be all the answers that we have there on the right-hand side. So 2, 3, and 3. Okay? Right? So if we're going to go ahead and solve for x, y, and z here, all we're going to do is we're just going to take the inverse of a on both sides. So we're going to have x, y, and z here, and that should equal whatever this matrix is inversed. So whatever this is an inverse times 2, 3, 3. Okay. Now, if you notice here, this matrix here is on the left. That is important here. Order matters when it comes to matrix multiplication. So A inverse here should be on the left. If you try putting this on the right, you will have a bad time, and it will tell you you have an error. So you can't be all willy-nilly and be like, I'm just going to multiply B times A. Like, no. You gotta do A inverse first and then multiply that by B. Then it'll give you an actual correct answer. So again, you could do this on the calculator here if you like, because this is just straight up matrix multiplication with its respective inverse. And this will give you what the answer for X, Y, and Z is going to be at the end of the day. Let's go ahead and take a look at how we can do that really quickly. We'll hit second and matrix. We'll edit a new matrix. We'll say it's a 3 by 3 matrix, and we'll put all the numbers we see here on the screen for A. Okay, so we hit second in mode. That'll clear up that first matrix there. We need second and matrix again. We need to edit another matrix, the matrix B. Now in this case here, matrix B, we have 3 rows and 1 column. So 3 rows, 1 column, actually. Each one of these numbers is considered a row for 2, 3. So that's what we'll put in here. There we go. We'll hit second in mode to go back to the main screen here. Now we'll call upon each matrix here. So second matrix, matrix A, hit the inverse key, multiply that by B, so second in matrix, call upon matrix B, and then we'll hit math and fraction here just in case, because again, the inverse can be fractions, you don't know. Let's see what we get. Okay, so we found our answer here of negative 2, negative 3, and 2. Okay. And that will be our final answer for that problem. Easy peasy lemon squeezy. Alright. Any questions about that problem there? It's as easy as that, ladies and gentlemen. That's all you have to do. Alright. Okay, and so that in effect, I don't have to show many examples for these questions because they're fairly quick and they kind of repeat stuff that we've done on the calculator before. So that is the end of chapter 6. Alright? As the end of chapter 6, that is exactly where I want to end off here for today. Okay? Again, the big reason why I want to end off here specifically for today is because we're going to be starting chapter 7 tomorrow. Chapter 7 is going to take some time, so want to at least get through chapter 6, get this stuff out of the way, and then we're going to focus on chapter 7 and do a section a day for chapter 7. So that's the plan. Plan is to do a section a day for chapter 7, so we get the tougher stuff there. So we're going to start conic sections here next week in chapter 7, so it's a little bit tougher. So I'm going to be spending a 1 day on each section for chapter 7, so we can get that out of the way, get the full understanding, get the full big picture. So matrices done, move forward with the tougher stuff. All right. That is the plan, my friends. That is the plan. We only have 5 sections of this. Will this stretch to 3 weeks? Yes. I guarantee you the thing is that in chapter 7, the amount of material in chapter 7 for each section is pretty heavy. So I'm going to go over it fairly slow, and I need to spend a day on each section. So I wanna be sure that things are taken care of, because there's just admittingly without just trying to be as like I said, transparent as possible. There's just a lot of stuff in Chapter 7 that I have to go over. So because they ask for a lot, so you ask a lot, and I have to give a lot. So the book, like, so even the problems are like, they'll ask like, hey, you got to do this, 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 and this, and like, okay, fine, let me do this. So, yeah. And even if this doesn't stretch the full 3 weeks here, Nicholas, for any time that we have left over, regardless of what it is, if you want to ask me questions or whatnot, homework questions, other types of questions, whatever, feel free to. We're gonna have to. You guys can ask, and I will be more than happy to go over problems with you. Okay, so just because the actual material ends doesn't mean that I just stop streaming. Of course not. I stream until the very end, the very last day. That's how it works. Okay, so you guys have questions. That's the plan for the free time that we may end up with. And you're like, hey, I don't quite get this question on such and such section or whatever. We're like, okay, cool, let's go over it. Okay, so I yeah, exactly. I'm not gonna stop. I'm not gonna stop because look, I have a fiduciary duty, number one. Number two, more importantly, is I have a duty to you to make sure that you guys understand stuff. So I should have channel emotes. I haven't had channel emotes in ever, so I have to find somebody to make channel emotes. I'm terrible at art, so it ain't gonna happen. My emotes are legendarily my drawing skills are legendarily bad. All right, everybody, let's end off here for today. We're gonna come back next week, ladies and gentlemen. Next week, we'll come back on Monday. All right. I want to thank everybody for coming out here to the stream once again here today. Thank you so very much. I love you all. Everyone, have yourself a wonderful weekend. We will see you back here next time. All right. And as always, stay safe, stay healthy, and most importantly, stay sane, everybody. Take care of yourselves. Have a wonderful weekend. And as my friends like to say, don't forget to hashtag it. All right. Have a great one, everybody. Take care of yourselves. Have a great one. See you later, everybody. Bye. Bye, everybody.